Hello everyone. I hope that you can hear me, and we're gonna start our today's lab. Uh, so let me share my screen. Okay, you should see my screen now. So today we're gonna talk about. We will continue basically UML. And today is session 3 about activity diagrams, right? So by the way, the slides are on the Moodle. You can download and have a better look at it. Okay, uh, so we started UML, right? We talked about class diagrams. First of all, of course, use case diagrams. We started from, let's say, structuring our idea into the some formal, let's say, requirements by use case modeling, right? Then after that, we covered class diagram, which basically helps you to, let's say, format or to have a better look at your classes within your project or within your system. So the next type of UML diagram is activity diagram. Uh, Basically, if you Google on the internet, there are many types of UML diagrams. I think that even they are being developed new types of diagrams each year or maybe each several years. But these types of diagrams that we are covering, they are popular and they cover most of the important, let's say, stuff uh, of your system. So today we're going to talk about activity diagrams and then state chart diagrams. Now let's focus on activity diagrams. So activity modeling, which is the which results in activity diagrams, it will help you to structure the behavioral, let's say, behavior of your system, behavior of your each element, right? So we will have different elements. Of course, these elements represent some of your, let's say, parts of your system, right? If you if you if you take a logical, uh, let's say, consideration at your system. So activity diagrams lets you structure these behaviors of the elements in a more advanced way, in a more nicely way. So basically, so activity modeling help you, let's say, structure activities and responsibilities of elements in system, right? So let's start with elements of this activity diagram. First of all, we have action states. So we know that each element of the system has some, let's say, state. I mean, it might be created, right? Or after it's created, it might communicate with some others, which is the real state. Then it might be destroyed, right? So activity diagram lets you define these states by introducing such action states: simple, initial, and final. As name suggests, initial says that this is the beginning or the when the object is created. Uh, so basically, yes, initial is when the object is created. Final is destroyed, right? So and simple when the object behaves normally. I mean, when it's created, right? So we will, and even simple also can be divided into parts. So we will see further. Uh, so basically, initial, we talked about it, and final, right? Final when it's uh, this is the last action we talked about it, right? So this is how the our initial and final and the simple states look like. For example, here we have initial in on the bottom, on the top of the diagram, uh, which is represented as a black, we can say that a hole, right? Then we have uh, simple states of actions. Project manager enters report criteria, project management, a system generates report, and printer prints report, right? Then in the final, we have destroyed state, which is represented by the bottom figure. Okay, so this is how you can represent the actions, the states of your actions, right? So now let's talk about flow transition. So the next element of our activity diagram is flow transition. So basically, this flow transitions lets you uh, have a order, lets you have a sequence of these actions. I mean, lets you define the sequence of actions. I mean, which action comes after another, and etc. So you can answer to this question by flow transitions. And flow transitions also can be divided into control flow and object flow. Control flow, basically, this control flow, uh, you can think of it as uh, from the perspective of actions. I mean, the order of actions, right? For example, if we look at this example, we can see that here we have three, let's say, actions, right? Project manager enters report criteria, project management system generates report, right? So these two actions basically comes one after another. For example, here we have a sequence, right? That is project management system generates a report comes after the first action, that is project manager enters report criteria, right? So uh, this control flow lets you define the sequence or order of the actions. So now we know that what is the first action, what is the second action, what is the next action. Okay, so this is the control flow type of flow transitions. Then we also have object flow, which considers or which looks at this, let's say, diagram from the perspective of objects. What does it mean? Now let's look at this diagram, which is a modified version. Here we can see that there are some uh, new elements, right? Report criteria and report. So these are basically objects. So these are basically, we can think of it like this is the output of the first action. So project manager enters a report criteria. This results in report criteria object, right? And this is also input to the next action, which is project management system generates report, right? Then it will also output some object, which is report, right? Then this is the input for the next action, which is a printer prints report. So this is object flow. Basically, this is the combination of object flow and control flow, right? But we can just omit the control flow, as we know from the object flow what is the sequence of the actions, right? For example, and also please pay attention to the how the actions are changed. I mean, here we have project manager enters data, right? So here we had project manager enters report criteria, which results in report criteria. So we have what duplicates here, and we can just remove, and we may have some let's say generalization here. Project manager enters some data, and after this action we have a result, we have an object, we can say report criteria. Here we let's say describe the diagram by object flow transitions, right? So we just omitted the control flow, and now we have a better idea. Okay, what is the result of some action, and what is the input, or what is the input to the next action, etc. Okay, so the next element of the activity diagrams is swim lane, which shows you to let's say focus on some part of your project. I mean, we know that if we have a lot of elements, and of course if you, let's say, modeled your system or project in a nicely way, they are modeled in a, they are structured in a modulate way, right? I mean, you're gonna have some models which are responsible for some tasks, and another models that are responsible for another task, right? So swim lane, by swim lane, you can also describe these areas, describe these models. And for example, here, uh, if you look at this, let's say, diagram, now you see a swim lane, which are basically these uh, vertical lines, right? Two vertical lines. They show that the part of the uh, system which your elements, we can say actions, are happened, right? So, or are performed. So for example, generate information basically uh, belongs to the project management system. If we think that you have a huge, or you have a large, let's say, system, and project management system is one of these, is one of the parts of your system, let's say, of your large system. So generate information belongs to this, let's say, area, project management system. And by swim lanes, now you have a better idea. Okay, generate information action is performed in this area, and other let's say actions such as enter data and print information, they are out of the control of project management system, right? So swim lanes lets you define your project even in a better way. And the next, let's say, element of the activity diagram is basically decisions. We know that uh, there might be some complex situations that one action may depend on some condition, right? Before going to the next action, or one action may go to several actions, several, let's say, actions, depending on some criteria. So decision lets you define even these conditions. For example, here we can see that this is also let's say improved or more advanced version of the last diagram. Here we can see that after printer prints information, we have some decision block. For example, here we have some criteria. If there are more reports, let's go back to the enter data action, right? And the process starts from the beginning. if there are no more reports, we can just go to the final action, which basically destroys the, let's say, actions. So decisions lets you define some more complex transitions, right? So these are decisions basically. And we have also another case where you might have concurrency in your actions. I mean, at the same time, you might need let's say multiple actions to be performed at the same time, right? So concurrency helps you to do so. Activity diagram has concurrency. Now let's look at this diagram where we have, let's say, on the right side, we have concurrency here, for example, print information and monitor for print requests. These two actions are performed at the same time or in a concurrent way, right? So even I mean, they are started at the same time, and they result in something, and they will also result into the this conditional decision block, right? So this concurrency helps you to structure your activity diagrams to have such, let's say, cases. So this is about activity diagrams, basically. So if you have questions, please ask.
In this diagram, there are two ways to call for the print information. Wouldn't it be happening that, for example, print information will start earlier than the monitor for printing requests? Because there is like arrow from report, which triggers the print for information.
Yes, basically, so you want to say that if this report, let's say, start this print information action, this means that whether this print information starts before monitor for print request, right? Is this your question?
Yeah.
Yeah, basically, these two flows, you see generate information to report, then from report to print information, and generate information to this, let's say, black line, which means concurrency block. These are basically one transitions, but described in two ways. So here we have generate information to print information and monitor for requests. This is described by control flow, but the below report, this is object flow description of the same transition. So we can say that whenever generate information results in report and report is sent to print information to be started, right? This means that the control flow is also performed. Okay, so basically this is the two version of describing the same transition.
Okay, understood. Thank
you. Yeah. Another questions? Okay, I think everything is clear. Then let's move to the next presentation. Just a second. So the next session is session 4 is about state chart diagrams. Okay, Now we know how to, let's say, define our system or our project regarding the life cycle of, regarding the actions of elements, right? How the order of actions, the sequence of our actions, how they can be structured. But we know that whenever our system has some elements or objects, right? They have some life cycle. In order to support some, let's say, memory optimizations, right? Which means whenever you will project some large system, of course, it's gonna consume some memory, right? But if you do not, let's say, consider some situations, which means whenever object is created and it lasts forever, it doesn't get destroyed, right? It means that your project consumes a lot of memory, and one day you're gonna have out of memory exception. I mean, sorry, error, out of memory error, right? So in order to prevent such situations, we have to, let's say, structure our system in a more advanced way regarding the life cycle of objects. Okay, whenever we do not need some object, let's destroy it, right? Then let's free some memory for other parts of system, for other objects. So state chart diagrams lets you to define such situations, which means that this diagram can help us, let's say, structure the life cycle of elements. So uh, we know that object can be created, right? Object may have relationship with other objects, which are also created, destroyed, and so on, right? So um, now let's get familiarized with the elements of this, uh, let's say, state chart diagram. So uh, as we know that we have state, right? State in state chart diagrams means that the state of the element which represents objects in your project or in your system. So state can also be simple, initial, or final, one of the simple or initial and final states, right? So, and also simple initial and final, the name suggests that initial, this means that whenever element or object is created, it's in initial, right? Or whenever object is destroyed, it's in final state. Okay, what is simple? Simple, this is, we can see that between initial and final states, we have simple, and also simple can also be divided into further parts, which are inactive, active, and suspended. For example, now let's look at this diagram, which shows simple states of an element. For example, here we have inactive, active, suspended. Right? So these are basically the states between initial and final. Okay, so let's say if we put everything together, we can have such, let's say, life cycle of an object or element. For example, here we have started, right? I mean, from the left part of the diagram, which is, we can see that, we can say that this is black hole, right? Then inactive, active, or suspended. These, let's say, states, they can be combined according to some, let's say, criteria we will see in the later slides. Then when object is not needed, we can just destroy, and we can represent such state by this figure on the right part of the diagram. Okay, so then uh, okay, we have states right here. We have initial, simple, and final, right? Okay, then how an object or element can or another with another words, how can we describe the transition from one state to another? Okay, how can we describe after initial whenever object is created, then it has let's say simple state. How can we describe this transition from initial to simple, right? So here we have transitions. Basically, transitions address this question, and also whenever you define these transition, there should be some, let's say, event or some, let's say, criteria. For example, uh, we can say that an element is in a source state, or then an event occurs, then some action is performed, then element enters a target state, right? So this you can describe some transition between some state to another state, right? So, uh, for example, um, when event, let's say, is performed, when event is fired, some action is followed. Okay, so you can describe the transitions in this, let's say, we can say that formula. So whenever event uh, occurred, then slash, then action. So this is basically the description of your transition. So even you can even describe the event in a more, let's say, detailed way. For example, here we have a, let's say, a specification that you can describe event name, parameter list, and guard. For example, event name, okay, the name of the event, right? The parameter list, for example, here we have user ID. Um, for example, this is optional, and uh, these are basically parameters passed to event, right? Then guard is here, we see that guard is um, inside the brackets, right? This is basically a condition which an event is fired, right? Okay, so now let's look at this transition which shows everything together. For example, we have some element and its, let's say, states, how they are, uh, let's say, transitions between these states. For example, first of all, the element or object is created, right? Then it goes to the next inactive state, which is simple state, right? Then uh, from inactive to active, I mean, in order to go from inactive to active, there should be an event called startup, which consumes user ID, and also when enough memory is available, right? So then from active to suspended, we have some, let's say, transition. Whenever server error or severe error, then from suspended to active whenever reset is done. So you see, and from active to inactive, there is also there should be also event file shutdown, event name shutdown, which consumes user ID, and the condition is system should be able to shut down, right? So this is basically how an object, this is basically the description of the life cycle of your object or your element. So now let's look at the next part of our transition, which is action, right? So um, you can describe action in the following way. For example, uh, we have return variable, then we have some target element to do some action, right? So target element does some action, and action name you can specify um, uh, after the dot, right? You have to put dot between target element and action name. Then argument list, which consumes this action. Uh, okay, so we talked about it. So now let's look at this diagram. So we have event start, for example, here, right? Startup user ID, which goes from inactive to active, right? So we are talking about transition between inactive and active. So there is an event called startup user ID enough memory is available, right? So this is event. An action is DT, which returns DT, right? Some, let's say, date time. I think. Then the action name is get date and time. Target value is some operation system, right? Then it consumes time zone. So this is the um, action description. So basically, this is how you can specify the life cycle of objects, uh, life cycle of one object, right? So this is basically a full description how you can um, describe the life cycle or how they live within your project or your system. Okay, so this was about state chart diagrams. If you have questions, please ask. We will discuss them. Okay, I see that. Uh, Sorry. So I hope that everything is clear. Now let's go to the next session. I mean, basically we covered the two diagrams. Now we can have some question and answer session, right? So just a second. Where is yes. Okay, so we are starting our QA session, right? Basically, who wants to be a millionaire, but we can call it as who wants to earn some points, right? So now let's go to the next slide. So please, guys, if any volunteer wants to answer to this question, please. So basically, these questions also cover the last our slides. So anyone?
May I try? I guess the answer is C, at the requirements activities phase.
Just a second. Okay, so your answer is C, right?
Yeah.
Yes, you are correct. And thank you for your response. So this is the correct answer, basically. And you earned 1 point. Okay, so the next question. Anyone wants to answer?
Can I answer to this question?
Yes, sure.
I guess A.
Are you sure?
I think so.
Choose the. Well,
Can I also make a guess? I think it's C.
yes, Insaf. It was Insaf, right?
Yes.
Yes, Insaf, you're correct. Mm, now, yes. So the answer to this question is C, stakeholder of the project. Why? Why not the client side of the project? Basically, we know that an actor can be someone, right, which interacts with our system, our users, some operators, administrator, right, or something. For example, backup system or some external, let's say, cloud system. So the client side of the project is not the best description for an actor. So the client side, we can think of it as a some, let's say, client mobile application, right? Or front end, let's say, the front end of our system, which allows users to interact with our system, right? That's why the question is choose the best description. Of course, the client side, it can be an actor, but we have some better, let's say, description for an actor, which is stakeholder. Stakeholder means anyone or anything which interacts with our project from outside. Okay, that's why this is a, we can say that this is a tricky question. So this is basically stakeholder of the project. Okay, so now let's talk about the next question. Any volunteer?
I try. I think this is A.
The best. Okay. What about non-functional requirement?
No, it describes the functions of the system.
Yes, you're correct. Thank you, Maxime. Yes. So basically, use case modeling describes the functional requirements of your system. Thank you. So the next question. So you have to choose the answer which correctly describes the use case itself. We can say that a use case instance or use case, just one instance, this description of one use case, not use case modeling or use case diagram. Anyone?
Can I try once again?
I can try.
Yes, please. Or
I think,
if someone has not answered, yes, Kirill.
I think it's B, the longest answer.
So your answer is sequence of steps, actions performed by system, and interaction between system and actor, right?
Right.
What do you think about the answer D, a sequence of actions performed by actors and system? Why this answer cannot be why this option cannot be the right answer?
Because it does not include interactions.
Yes, you're correct. So basically, use case should also be able to, let's say, describe the interaction between actors and system, right? Okay, thank you, Kirill. Okay, so now let's go to the next question. Okay, what is an activity modeling? Can you find the best description for the activity modeling here? Anyone?
Can you hear me?
Yes.
I believe the correct answer is, let me think for a bit, B.
Okay, so behavioral modeling of a system regarding activities and responsibilities of its system. And you're correct. Thank you, Jamil. Okay, yes. So this is basically, we talked about this in our current session, right? Okay, so choose the option which could be the state of an action. What do you think? What can be the answer? Yes, sure.
I think it's final, D.
Okay. Yes.
Initial and final.
Yes, yes. This is basically correct answer. So neither of other options can be the state of an action. Thank you, Anna. So now let's go to the next question. So choose the best description for the flow transitions, Anyone? Daniel, you want to try?
Yeah, maybe B.
You think that flow transitions show how action states are ordered or sequenced, right?
Yes.
Yes, you're correct. So basically, it shows how action states are ordered or sequenced, right? So thank you, Daniel. So now let's talk about the next question. So this is, you see that this diagram and you see the part or block, which is, let's say, surrounded by red oval. Can you find the correct description to this? What block is this?
It is concurrency.
Yes, correct. You're correct. It was Timur, right?
Right.
Yes, thank you, Timur. So it's basically the concurrency block. So okay, now let's talk about state chart diagram. So can you choose the best description for the state chart diagram? Anyone, even if you have answered, please, you're welcome.
May I try?
Yes, sure, Leonid.
I think it's B. It describes the system regarding the life cycle of its elements.
It's B, right? You answered B.
Yes.
Yes, you're correct. So basically, so this is state chart diagram. It's about life cycle of elements. Okay, thank you, Leonid, for your answer. Okay, so can you find the which state is shown in the picture below?
Can I answer again?
Yes, sure.
Oh, this is the final state. C.
So basically, yes, this is a final state. Which final state which you can represent. Okay, basically this is the last question of today's quiz. Thank you for your participation. Today we're gonna finish our labs earlier. So if you have any questions, please ask, or otherwise our lab is over. Any questions?
Seems like no.
Okay, then thank you guys. So bye. So we will meet on Wednesday next week.
Goodbye.
Bye.
Bye.
Bye. Thank you for your
Goodbye.
participation. Bye.
Excuse me. So the okay, attendance is not counted today, right?
Yes, but you earned some points. That's why your participation is something like it matters.
Okay, but on days like this, like we have spent only close to 50 minutes. And you said that 60 minutes is required for at least attendance. So how is it going to look like?
Well, today is we're not gonna count attendance, which means even if the guys who didn't attend, it means that they also have attendance score. But you attended, it means you also have attendance points. I mean, even if our lab lasted for 50 minutes, and plus you earn some points. I mean.
No, I was asking that, okay, suppose that on Wednesday we still have such labs that last for 50 minutes.
No. On Wednesdays, on regular schedule, we're not gonna have such short meetings. If the lab, let's say, lasts for 15 minutes, then okay, then it means that you attended. It's not your fault, right?
Okay, thanks.
Okay, thank you. Bye.